section formula. So I have a scenario wherein we have a long stick, and the thing is, at one end we have a weight which is double that of the one which is at the back. So if this is 10, this is 20 kg. So here we are, we have a task of carrying it from one point to another point. Okay, so that nothing falls off. So if I hold it too far, too forward, there's a chances that it will fall back. And if I hold it too back, this will fall. Okay, so it has to be balanced. So there is a point somewhere in the middle, like something like say here, right? So wherein if we keep it, if we happen to hold it at that exact point, okay, so that's too long. That's shoes is not proper. Okay, that's better. Okay, head is important, and we have the hand. Right, if I hold it at this point, right, it will be balanced. This won't fall back, and this won't fall front. So the question is, where is this point? So if we say we have information about the coordinates of where this mass is located, and this length of the wood or any kind of rod has no mass or zero mass, and only we have these two masses, okay, located at 10, 30 and 40, 30. If I know that, with some kind of physics or kind of common sense, I get to know that this length should be 2 times that of this length. Okay, again I'll repeat. So the physics tells that if I have double the mass than what is over here, if I hold it in the ratio of 2:1, that is, if this is twice the length of this, say this is 10 meters, so this will be 20 meters, then the system will be balanced. That is, it won't fall forward or it won't go back as well. So this is a ratio dividing this line, joining the two masses. Okay, so we know the ratio where we have to hold. Now we just need the coordinates. Okay, so we need this exact point. To find this exact point, we use section formula. Right, the formula goes like this. So we need x and y so that this particular condition satisfied. So we know the coordinates, and using the coordinates and stuff, so we have a formula xm plus m plus m, ym divided by ym plus m again. So it's not completed. You have to go with 1 2 2 1 and 1 2 1 2 2 1 and 1 2. So basically you can remember this with the call center formula 1 2 2 1. Okay, so we have 1 to 1 as a call center number, right? So here we use 1 to 2 1, and we just have to write xm ym and divided by m plus m. Okay, this is the basic formula. This we need to know. By knowing this, we can find this coordinate. Oh yeah, what is this m and m? I told m1, m2 and all that. Where is this m and m? So if I take this point as x1, y1, and this is x2, y2, this will be m1, this part of the ratio, and this will be m2. Okay, so that's where you get your m1 and m2. Now all we have to do is solve it. So x is equal to x1 is 20 into m2, that is 1, plus x2 is 30 into 2, entire thing divided by 3. So this is equal to 100 by 3, around 3.33 bar, 33.3 bar. While we have y is equal to 30 into 1 plus 30 into 2, entire thing divided by 3. So this is 30. So basically this coordinate is 33.3 bar comma 30. Okay, that's where the point is. And if you hold it over there, it will not fall aage or piche. It will be just straight. So this is your section formula. And this is a small use that I showed. I mean, it's not small actually, it's quite, the usage is pretty huge. So where else do we use section formula? Centroid, in center, center. So in your basic geometry, we use, and we also use in finding the center of mass, which we just did. Equilibrium point, again, something which is, both are kind of related to each other. They are related to each other. So a bit more practical example is our planes, right? Commercial planes or whatever planes. So these planes have to be balanced, right? This will be balanced only if the people sitting inside have seated evenly throughout. It should not be one-sided. It should not be like everyone sitting at the back, everyone sitting in the forward. No, the plane has to be balanced. And even the luggage, which is at the bottom, it's below your bottom of your where you sit. It's just below that. There's a huge chamber. It's around 5 feet kind of thing. I mean, small planes. So in that space, they keep your luggages, and they just don't keep it at the corner or something. It is distributed evenly. So when you are giving your bag to the person who collects it at the ticket counter and stuff, they weigh your bag, give this information to a person. This person does kind of some kind of calculation and stuff, and he tells, okay, this is the weight and this is how it will be distributed, and that this will be given to the captain of the plane. He or she will know, okay, this is what the load is. I mean, and this is what how much gas I'll require, right? And this is the number of people and stuff. And this is how, I mean, this is what I get by having a simple knowledge. The complicated version, you can talk to someone who knows about this a lot more, even a pilot itself. Okay. So the idea of center of mass is very important for a flight, and center of mass is pretty much dependent on the location. And finding the location, we can deal with coordinate geometry, and coordinate geometry. And we have to come back to, we have to use section formula to finding such points. So please make a note of this in your formula list, and there is a lot of problem that will come across.